Hey everyone, welcome back to JPStreetPerformance. We're bringing you episode 13 of the Frank and Yoda build/restoration. We're going to change it up for you guys a little bit this time. I know we've been doing a lot of metal work on patching floor pans, fixing metal. We still got to get the rear end fixed here. But today we're going to start, this is going to be day one of teaching ourselves how to design a cantilever, aka push rod suspension for the rear of this. We're gonna start to kind of clear out the back here, take some measurements and start on Autodesk Fusion, teaching ourselves how to kind of design the bracketry. We need to figure out what coilovers we're gonna run. So if you guys like this kind of thing, hit that like, smash that subscribe, and stay tuned for the video. All right, so we're gonna start with removing all these extra panels. They're non-structural. We'll get them out of here, and then that way we have access to our actual floor pan and our factory shock towers, and then we'll kind of start designing from there. All right, so we got all the panels out of our way. We're gonna go ahead and scrape this gunk off here because there's a couple raised spots we need to account for as we're building the structure in between the two shock towers. Plus, we wanna also make sure we're leaving enough room for the roll cage we're gonna eventually build. So we'll go ahead and get this junk out of here, and then we'll start to kind of do some, probably some cardboard aided design. And then we'll probably move that into actual computer-aided design once we take some measurements, get our notes written down. And again, this is just day one of designing it, so kind of going to be a shorter video for you guys, but kind of what to expect, and you can follow along as each build as we progress with designing it. We got to, like I said, find out what shock size or coilover size we're going to do. I'm thinking 12-inch. 12-inch coils more than likely. We want to try to keep it a 1-to-1 ratio on the cantilever arm. So, but we want to have a couple different adjustments because this thing is going to be tracked and possibly drifted as well. So we want to have as much tunability in the suspension as we can. The reason we're doing this is for these Celicas in particular. They do not have enough room to fit a coilover inside these towers here. And yeah, I could widen it, but it's multiple layers of body panels, which is kind of dangerous on a unibody like that to cut into multiple layers. So what we're gonna end up doing is just taking out a larger chunk of this. We'll probably end up putting a part of the cage around where the push rod comes through, and then anchoring to that plate as well as the cross plates we're going to do, so it's really just structurally sound. So. So the very first part of this process is going to be taking very loose tolerance measurements, kind of getting an idea of what kind of materials we're going to need size-wise and everything. So we got, let's get that out of our way, point to point, 29 1/4. Just drawing our towers here. Kind of come up and then they kind of curve back and go over. So we're going to go from here to here. It's 29.25 inch. Height wise, now you got to remember, you got to have room for the rod to come up and for the suspension to have room to articulate. So we're going to go, top of that is 6 inches where the shock comes out. So we want to add an extra, let's say 3 inches. I'd say 3 inches. And go up to 9. Let's double check that. I'll say 9 or 10. Let's see. 9. Is that enough? Give it 3 inches of down travel. Let's go up to 10 inches to be safe. 10 inches. I think 10 inches is going to be our magic number there. So we're going to go from here to here at 10 inches. Just again, this is just a crude drawing, nothing set in stone, just kind of getting an idea. I've got to figure out, this is slanted back just ever so slightly, so we should be good squaring this up. We just got to figure out if it comes up to 10, that's up here. And we mount the pivot point here. How much distance do we have? We need something with structural rigidity, so I think we're going to do a three-inch wide, 3-inch x 1-inch tall rectangle tube for structural rigidity on the lower section, which will bring us up an inch. And then we can notch and weld around these raises with the tube. That should be no more than 3 inches wide there. Yeah, that's like, it gets a little narrower, but down here it's definitely 3 inches wide perfectly. So, okay. We're going to start with we'll order a 3-inch by 1-inch tube that's 29.25 long. Let's go directly in between there, and then we can, that tube will lay flat right here, and then we'll measure our cantilever suspension. We're going to figure out how big these the cantilever arms are going to have to be. So we want to keep them 1-to-1, but we do want to have them big enough for adjustments. So if worst case scenario, we may have to lengthen these rods to go even higher so the shocks can come down at a steeper angle. But we won't really know till we kind of start fabricating this thing as we go. We're going to grab some cardboard and kind of get a semi-design going. And yeah, we'll kind of go from there, guys. All right, I think we're going to change the lower section to 1.5 inch instead of a 1 inch, because 1.5 inch by 3 inch is a pretty standard rectangular tube. So, so that means on our brackets here, we need to take 10 inches what we wanted. We need to take 10 inches and reduce it by 1.5 inches for its offset. So we're gonna have 8.5 on our height. So we're gonna grab a pin, let's grab a ruler, and kind of draw this out and dropping stuff, you know, that's always fun. All right. Okay. We're gonna kind of draw this out real quick. All right. So we need 29.25. So we're just gonna draw this out all the way down to 29.25. Okay. All right. Then we need to go up. Looks pretty square. I'm gonna go 8.5 up. Since we're gonna be sitting on a 1.5 by 3. Okay. All right. Same thing here. 8.5 up. Get it lined up as squared as possible. It's pretty damn squared. 8.5, like so. Okay. Now, what we want to do, we don't need this to be, actually, we don't need this to be one full piece because we're going to have that bar tied in. We could weld our shock tab straight to the bar, but for now we'll design it this way. Let's triangulate it with a 45, and then I don't know how far back we want to go yet, but from the top of it, right there, actually, let's do it this way. There we go. We're going to draw this line, but we're not going to cut the whole thing. We just want to have a nice 45. Same thing here. This is just proof of concept, guys. We're just doing this. It's a proof of concept. So okay. Now, I think actually if we go right here, okay. Let's cut this out and see if this idea is working. So I got a 2x4 laid in there because it's exactly 1.5 inches. So this is kind of what I'm thinking at the start of my design here. That kind of set in there a bit. Like I said, we'll have to clearance the for the raised sheet metal, but I think we go with something like this. I think that's gonna work, and then we will have the shock mounts. Let me get the other piece made up real quick. All right, so the nice thing about this is we can make it whatever width we need it to be when we get to that actual design part of it, you know, depending on what size bearing is going to go through here. But for now, let me grab some masking tape. This is just kind of a loose fit, you guys, but this is the best way to start, is just start designing. And I know we are going to want this to be flush with this side here, so we're going to do that right there. That one's there. Okay. This one here, like so. This needs to go in there a little bit, so peel that off. There we go, right there. Okay. That'll be like that. And this rear section, climb in here real quick. Whoa. Okay. Again, it'll be more level once we notch out all this stuff, but I'm thinking that is a rough fitment of our initial cantilever suspension. So let's take another measurement. If everything is right, these should be about 10 inches at their peak, which they are right on the money. 10 inches there. 10 inches there. These edges will be rounded off for strength, but I think I want the cantilevers to actually pivot inside of our reinforcement bracket. What we need to do next is I have a piece of 5/8 rod, just a scrap rod here. We need to go down and see what our length is going to be. So we need to remove the rear shocks, and then we'll see where our rods are going to come up. All right, so I actually decided to just do 8.5 inches, and we're just gonna get rid of that bottom pipe and just notch this out to clear those humps. So let's scribble this out. So at 8.5 inches, we should be able to fit, we'll box that in like I said, and we should be able to fit a fairly decent size cantilever in here. Again, we'll probably come up, we need to see how much travel the coilovers are going to have before we design this, but typically most shocks run between 1 and 5 inches depending on the shock. So if we came up, call it 3 inches, just meet in the middle, Just kind of what I was thinking. 3 inches of travel would be about right. Again, I'm learning as I go, guys, so there's probably easier ways of doing this. I don't know. I think this is going to work, though. So yeah, if we came up to 3 inches, that would be about even with that. So I cut out a little piece of scrap. This is by no means any calculated part. I'm just trying to figure out lengthwise. I want to have enough meat for the cantilever. So if it came up to here, thinking we could do some back straps this way to box this in, and then we'll box this in for where the shocks are going to mount, and that should be strong enough. Weld it straight to the body on both sides, plus being boxed in, reinforced, boxed in on the back side, boxed in on the front side. We just need enough room for this to articulate. So I'm thinking maybe a 3x3 cantilever might be about the right size. All right, this is just an actual 5x5 with the corners cut out. So just kind of hand drawn, but I think we taper this edge, round these edges off here like so. That way this can go in down here. Yep. And then we'll have 12 inches or 13 inches. Roughly. This is just a rough fitment, guys. Okay. About there. That'd be, yeah, that looks like that would be about centered. Make sure there's enough meat. Oops. Rough hole right there. Granted, we know this hole will be much bigger because the bolt will be much bigger, so we'll have to calculate for that as well. But for now, let's just get this thing placed back in here just to see proof of concept. Okay, we're rolling forward. Let's get a block of wood under this tire. Okay. Hey. Okay, this came up. That should be about our 3 inches that we wanted. 3 inches on the dot, nice. And then if we did our 13 inches this way. Right there, center to center. We want to mark that on our cardboard. sure that's close. 13 center to center. Okay. So that means we should, in theory, have more than enough room to fit our other one here. Oh yeah. There we go, you guys. I think that's kind of where we're starting. We'll have this cantilever here. Suspension will push, which will then push on the shock. We'll make sure it doesn't bind. So that's the biggest thing. But for now, I think that's the start of our preliminary design. Things can change as we go. All right, you guys, as you can see, this is our preliminary design, a little closer look. There's our cantilever here. Again, things might change size depending on how far up the rod comes, how much travel. We need to order the shocks so we know how much travel the shocks themselves have, sorry, the coilovers. We need to order the rods once we get kind of everything situated. But for now, I think our main frame is going to be how we're going to design it, and then we'll box it in, as I was mentioning earlier, wherever we can to reinforce it and then weld it to the body with some, we might even do some support gussets in between. So anyways, you guys, I hope you're learning along with us on this engineering, this cantilever pushrod suspension. This is episode 13 of the Franken Yoda. It's kind of a fun build. We're just kind of doing everything we never did before. You know, we've done a lot of performance stuff like install engines, that type of stuff, but we've never really gotten into fully fabricating things from scratch. And this one's going to be a fun project. We're going to teach ourselves how to build a roll cage on this project. We're teaching ourselves how to work with CAD using our homemade plasma cutter here, so our CNC table. So if you like this kind of stuff, please like and subscribe. It really helps the channel. We want to keep bringing you guys content. We want to be able to focus more on this type of stuff for you guys. So anyways, thanks for watching YouTube, you guys, and following along. We appreciate each and every one of you guys. Thanks a lot. Till next time.